Welcome back, and in the last video we were talking about limits, and now limits of sequences, that is, and now we're going to get some practice finding limits. But before we do, just a couple things that we want to make you aware of, other tools you can use. In the last video we connected the idea that if we can find the limit of a function, right, for any real number, then we can find the limit of a sequence, because we're just looking at the integer values of the from the function. So for that reason, the squeeze theorem applied for functions, so therefore it's going to apply for sequences. And so here, our standard squeeze theorem, if we can kind of sandwich our sequence of interest, the Bn sequence, between two known functions that are easier, and those functions or those sequences both have a limit of L, then we can say that the limit of Bn is also going to be L. Similarly, absolute convergence actually ends up being extremely useful in one of our exercises, but what it says is if we can look at the absolute value of the sequence and say that the limit of that absolute value function is 0, then our function, or our sequence is going to also have a limit of 0. Okay, so here we go. We have a few examples. We want to determine if it's convergent or divergent. If it's convergent, find its limit. Now, most of these you might want to have a little bit of intuition going in, because it kind of helps you figure out which direction you want to go. So the first one here, -1 to the n all over n, we realize that as we increase the power of n, or the value of n, so like 100, 200, 500, million, right, the denominator becomes a larger number. We're dividing 1, or -1, by a large number, effectively making it 0. So we're thinking that this is convergent, but now how do we show this formally? And the idea is absolute convergence. So limit as n approaches infinity of the absolute value. We're going to ignore that error. Don't know why we're getting it. But we're going to look at absolute value of -1 to the n over n, right? And the limit of the absolute value, well, that's just the limit as n goes to infinity. And then the numerator would be, +1 or -1, and the absolute value of that is 1. Denominator is just n, and this is going to be 0. So then the limit of the absolute value is 0, therefore limit of an, if we call this an, as n goes to infinity, is 0 by absolute convergence. Okay. The next one, again, you might want to think about it for a hot minute, but again, as we increase power, or the value of n, right, we're effectively making the inside 0. Cosine of 0 is 1. Convergent to 0. So how do you show this formally? Well, you could try the squeeze theorem. You could certainly say that, cosine of 2 over n is equal to 1, less than or equal to the sequence of 1, and that's certainly convergent, right? The only tricky thing is to figure out what this lower bound or lower function is. It ends up that if you look at -1 over n plus 1, and then for n greater than or equal to 2, this is a true statement, and we can so this is going to be under the cosine of 2 over n. And as we look at the limits, so the limit of 1, right, is 1, and the limit of -1 over n plus 1, as n goes to infinity, is also going to be 1. Okay. So here we've squeezed it, and then therefore by the squeeze theorem, by squeeze theorem, limit of cosine 2 over n as n goes to infinity is 1. And this should have been 1 from the get-go. Okay. All right. Next one. This one, again, you need to have a little bit of intuition about this one. It ends up being that, we're looking at exponential growth here. So this is growth. This is decay. And then this is growth. And this is decay. Or this is constant, right? Constant. So we're thinking as n gets really, really large, right, decay is going to effectively be 0. So this is going to go to 0. And then this is just going to be essentially nothing. So this is the idea where you can look at highest values in the numerator denominator since you have a rational function. So this is really going to be, say, the same as e to the n over e to the 2n for n sufficiently large. Okay, that's kind of the shorthand notation for that. And when we look at that, okay, this is the same as 1 over e to the n by laws of exponents, and this is going to approach 0, so this is going to be convergent. Okay, that's just an outline of the logic. How you would do it formally, you would say, in terms of values, you can say if we call this bn, right, the limit as n goes to infinity of bn as a value really is going to be the same as the limit of, as n goes to infinity, of e to the n over e to the 2n. I keep writing that incorrectly, which is equal to the limit as n goes to infinity of 1 over e to the n, which is 0. Okay, and keep in mind I'm not saying that the functions are equal, I'm saying that the limits are equal, so that's why this sort of expression is valid. Last one. You might be a little confused. What is R? That's a very good question. That's where, if you're given something like this, you need to think outside the box. You need to develop cases. Okay, so I want to say that the limit of r to the n as n goes to infinity is, and then there's a few different things it could be. What if r, so if r is equal to 1, well, then we just have 1 to the n. Ooh, that is boring. That's just 1, right? So it'll be convergent. So now, what if r is like 1/2, right? 1/2, you take repeated powers of 1/2, that's going to continually get smaller. It's going to approach 0. If r is less than a half, or less than 1, and it's technically in absolute values. Okay? And then, and I should, yep, that's fine. And then if r in terms of its absolute value is bigger than 1, it is going to, actually, I'm just going to say bigger than, yep, bigger than 1. We're going to get infinity, right? We'd have 2 to the power or negative 2 to the power. It's going to get larger or just not converge. So that's what we'd say. If r is equal to -1, then it's going to alternate. So it's going to dne if r is equal to -1. Okay, so we get convergence in these two cases, convergence, and then in these two cases we get divergence. Okay, so when you're finding limits of sequences, make sure to have kind of an idea in mind, think through it a little bit, play with numbers, see what you get roughly, and then try to establish the limit formally.